Okay, here we go. Looking on page 15, playing with section 1.4 of equivalent fractions. On question 9 we have an example of a fraction rule. Now what I've got there on the screen is different to what I have on question 9. It's more extensive and it's a great way of showing how fractions can be equivalent. For example, just to run my mouse over that, can you see that a half, for example, is the equivalent to 2/4 in terms of space? And a half is the equivalent to 1, 2, 3, 4/8. If you want to run across the whole bar, a half plus a half is a whole. 1, 2, 3, 4/4, I think you can see, makes a whole. In the same way, 8/8 across there makes one whole. And we've got 1, 2, 3/3 again makes a whole. Let's begin to write some of these down so that we can appreciate the beauty of this wall. So if I put it down here somewhere, we've got a half is equivalent to that one plus that one. Well, that's 2/4. What have we got? 1, 2, 3, 4. Well, that's 4/8. As you can see, they take up the same amount of space in the wall. Let's have a look. Let's go over here now. We have a half is equivalent to 1, 2, 3. That's 3/6. Here I go. Half equals 3/6. Let's try something different. I've got a fifth equivalent to bang bang 2/10. It's not difficult, is it? If I go for an entire half, let's just change colour to highlight the thing. If I go for a half for that one, I think you can see a half is 1, 2, 3, 4, 5, 6/12. So I'll write it here. A half is 6/12. What else can we say? Let's go over here again. A half is 1, 2, 3, 4, 5/10. So write it down. A half is also 5/10. I think you can see the beauty of this elegant little arrangement here. Let's change colour again. We'll go for that one. Let's do the thirds. I've got a third there. It's equivalent to 2/6. Let's write it over here. 1/3 equivalent to 2/6. Where else can we do? If I take that third there, I've got 1, 2, 3, 4/12. So over here I'm going to go 1/3 is 4/12. That's lovely. I think that's really good. I want to tackle one or two questions also from the book based upon this, and so what I want to do is not use the wall but just change the page like so. I'm ready to start something related but slightly different. Let's just use a completely different colour just to make life interesting. Let's try using that purple one there, and we'll take it away right now. So working up here now on the screen, we've got question 8 that says 5/9 is equivalent to what out of 18? Well, you can draw yourself a wall, or you can say to yourself, how do you get from 9 to 18? Answer, multiply by 2. Therefore, to keep the proportion the same, you multiply the 5 by 2 and get 10/18. Alright? Next one along. Something over 9 is equivalent to 14 out of 18. You can say to yourself either, how do you get from 9 to 18? Multiply by 2. Therefore, what number times 2 makes 14? Well, the answer is 7, isn't it? You could have done it a different way. Let's look at this. So what out of 9 makes 14 out of 18? Now 14 out of 18 is our completed fraction. So we can say, how do we get from 14 back down to 9? We divide it by 2. So how do we get from 14 back down to a smaller number? We divide that by 2. 14 divided by 2 still gives us 7. So both of these methods are correct. So you can have a tick each because they're good boys. Now how about this one? Something out of 6 is 12 out of 24. If you don't like working backwards like that, then we can rewrite it and say 12 out of 24 is what out of 6. So we're working from left to right. We still don't multiply up though to get to 6. We have to divide it down, so to speak. So what do we need to divide 24 by to get down to 6? So 24 divided by 4 makes 6. Therefore, if we divide 4 into the 12, or 12 by 4, we will get 3. I think that's correct, isn't it? Wonderful. Can that go further? Yes. 3 out of 6 is a half. We could have, of course, done it in one step. Let me just show you how we do that. 12 over 24 becomes what out of 6? And actually, I'm going to backtrack on that. I quite like it. They actually wanted it to remain as 3 over 6. I'm not going to reduce it down to half, although that would have been correct anyway had they asked us for that. We could have got an equivalent fraction whereby they've said 12 out of 24, how much out of 6? And how much would that be out of, say, 12? So that's a completely made up question. We don't just have to have 2 equivalent fractions, we can have 3, of course. So back down to the bottom, how do you get from 12 to 6? Divide by 4. So 12 divided by 4 we know is 3. Can't quite fit it there, so I won't even try. How do you get from 6 to 12? Answer, multiply by 2. So 3 multiplied by 2 is 6. Now if you study all these, let's just change colour, highlight it in yellow, they should be nice and loud. So here we go. We got 12 over 24, exactly the same as 3 over 6, and 3 over 6 is exactly 6 out of 12, and they're each worth a half. Is that alright? How are we doing for time wise? We're playing with the equivalent fractions using the fraction rule. It's quite useful visual impact in terms of different fractions being equivalent to each other in terms of the amount of space they take up on a wall. Again, you can refer to question 12 on page 16, or back at question 9 on page 15, or look back at the previous vid, and we'll stick it all together and make a half decent go at it. Question 13 combines all these ideas. It talks about a chap called Joe. There's Joe. It talks about a chap called Sam. Not a problem. It says that a bar of chocolate is split into 24 pieces, and Sam eats 4 of them. So Sam eats 4, and then it says Joe has another bar of chocolate the same size, and it's split into 30 equal pieces. So Sam's out of 24 and Joe's out of 30. And the question says, how many pieces of that bar should Joe eat so that he eats the same amount of chocolate as Sam? So if we call Joe's bits of chocolate X out of 30, if it's the same size chocolate, it will have the same area, the same amount by weight. So we can say Joe out of 30 equals Sam's 4 out of 24. What we can do is cross multiply as follows in order to work out what Joe's mystery X is. So going with the yellow now, I could say 24 you get over there and get multiplied, and 30 you get over there and get multiplied. Going back to black, say we have 24 lots of X is equivalent to 4 times 30. So 24 times Joe's X is equivalent to 120. I can then say Joe's X's is 120 divided by 24. That looks quite frightening, doesn't it? Let's just reduce it down a little bit. That's like saying 60 out of 12. Still looks quite scary. I think I'm going to go with 30 out of 6. Now my brain can handle that without a calculator. 30 divided by 6 goes in exactly 5 times. So what we got? We have Joe eats 5, snapping there, 5 pieces of chocky. There you go, because I can't really spell chocolate. Is that alright? So that's about it really. What else can we do here that could be useful? Don't want to go on to 1.5 just yet. I'll save that for another little video. I think if we do 1.5 and 1.6 together, then we finish the whole of chapter 1 in brief. but I might do a few from the assess. Now assess is on page 21 if you want to look ahead. The maximum grade for this fraction topic is D, so it ranges from E to D. You can sort of study, go ahead in order to get yourself prepped up for the next video that's coming up. I want to stop it right now and try and merge this with the other one.